Hi everyone, in this video we'll take a quick look at some of the performance characteristics of Scrapy. So unlike some of the other videos that have been published on the channel, which is more around spending more time on the keyboard and doing demos, this video is basically showcasing some of the results of some very basic performance benchmark using Scrapy. Now, if you're either evaluating Scrapy as a potential candidate for doing web scraping, web crawling, or considering building your own frameworks or thinking of other alternative frameworks to Scrapy, hopefully this video will help you understand some of the basic performance characteristics if you're considering Scrapy. Now, Scrapy itself, of course, can be used broadly in two ways. So one is if you're building focus crawls, so if you're trying to scrape specific websites and do some data and content extraction, structured content extraction from these specific websites. Or the other option is if you're looking at what's referred to as a broad crawl. So that's pretty much like what Google does in the sense it crawls and indexes pretty much every website that it comes across. So in essence, this video or this particular performance benchmark is more to do with the latter, that it's about benchmarking against broad crawls, in part because broad crawls give us a better idea in terms of the overall characteristics of how Scrapy works as opposed to a focus crawl where there's a huge dependency on just the underlying performance of the particular website or websites that you're crawling. So having said that and setting context again in summary, this is basically about the performance when doing broad crawls. However, the basic benchmarking that was done here should apply to very much every single focus crawl that you're doing. Now, in terms of the actual um, the the details of the benchmark itself, what we'll go through is looking at basically the URL crawl strategy itself. So how are we getting the links and how do we traverse the links? We'll take a look at the basic hardware, the hosting, the operating system specifics. You'll get an idea in terms of what the benchmark, the environment of the benchmark itself. Then we'll take a look at the configuration and some of the basic code that was implemented in Scrapy. And then finally, we'll take a look at the results. So what I've done is I've taken a base configuration and done the first run. Actually, I've I've run it twice, but I'm just clubbing it as the first run. Um, Seeing some of the performance and behavior of the crawl have then changed the configuration and then ran it a second time. So that's basically how the benchmarking was done. And again, just highlighting that the benchmark uses basically the out-of-the-box capabilities of Scrapy and only basic changes to the configuration was done. It did not involve any advanced tuning and performance, and all configurations were basically done from within Scrapy. So no optimization outside of Scrapy itself was performed, like say for example optimizations for DNS requests and network etc. Not performed. So it's a very basic performance benchmarking. And just highlighting that this was again a broad crawl, and if you are trying to do some performance benchmarking for your specific requirements, highly recommend that you do your own benchmarking, and the strategy or the scheme that you follow for your content extraction is bound to have different network, CPU, and memory characteristics and pressure. So, highly recommend that you perform your own benchmarking. So in terms of the crawl strategy itself, so utilizing Again, it's a broad crawl, so it's not a focus crawl. Using the crawl spider class as the base class and not the default spider because we have to do recursive crawling. In terms of the actual rules itself, so given that this is a broad crawl, basically allowing for all sites to be indexed. So I mean, not restricting the list of allowed site. However, have restricted the number of sites that it has in the deny list. Essentially, I've taken the top 100 sites from Concast.com. It's basically a list of the 100 most popular websites on the planet. So if you're wondering why I've put that in the deny list, uh, given that I did not want to run this crawler forever within a single site, thought it would be helpful to get a much broader sense of the lay of different URLs that would be crawled if I put the top sites in a deny list. So as an example, imagine if you will that the crawler hit a YouTube.com link. So then it would end up being in YouTube and crawling for YouTube sites for a very, very long time. And since these sites are so massive, it would skew the overall performance characteristics. So hence, have set a list of deny sites, and that was basically the top 100 sites and a few others outside of that. In terms of the path itself, basically we are traversing based on all anchor tags, so it's pretty much following all the anchor tags. So of course, if in this particular case, if the website used some kind of JavaScript based mechanism like Ajax, for example, it wouldn't have worked in this particular case. But vast majority of the sites still use server-side based encoding, or it could be static or dynamic, but it's still server-side rendered HTML. So it still allows for us to basically navigate recursively using anchor tags. So that's basically the scheme, if you will, in terms of building the recursive broad crawler. In terms of the hosting environment, um, the the thing in this particular case, I've used Azure, Microsoft Azure as a cloud hosting platform. So could have used anything else. Could have been Amazon Web Services or even other VPC-based hosting like say for example VPS-based hosting like Linode for example. But in this particular case, the benchmark I've used Microsoft Azure. The server itself was hosted. It's a VM, so the server is hosted in the US. Thought I would show a better performance benchmark when it comes to latency, given that vast majority of websites are still hosted in US data centers. So to reduce the latency, the network latency, have hosted this one VM in the US data center. In terms of the actual spec of the server itself, so again, Azure has different sets of VMs. It might be different from what you would get if you ran your own VM, or if you have yeah, if you're using some other cloud hosting vendor like Amazon. So just so that we can compare apples to apples, if you're trying to run it off of a different hosting provider. I've used the DS series, the DS2, which basically has 2 cores and 7 GB RAM. One of the things I wanted to make sure was that we have at least 2 cores which would allow for some level of concurrency and parallelism. And Scrapy itself is quite memory hungry, and we'll see that as we go through the performance benchmark results. So wanted to make sure that there was enough room to play with about 7 GB of RAM. Now, if you're trying to run it off of your own hardware or want to set some similar benchmarking, have just for the sake of understanding what the underlying chipset is, I've run these commands here. So we know that the DS series, or in this particular case DS2, uses the more powerful Intel Xeon-based chipset, 2.2 gigahertz, and again could have used the A series, but the A series is not as powerful as the DS2 series. Finally, in terms of the DNS, as I mentioned, we are using the Azure's internal DNS server, so we are not using any custom DNS server. And again, one of the big benefits of doing some of these initial benchmarking off of a cloud-hosted vendor's server is that since you're going to be making a significant number of domain name requests, if you ran it off of your personal PC at home or even in your office network, you may want to be mindful about how ISPs may blacklist your IP or certain range of IPs, as it might be a violation or possibly even something like a denial of service attack on the DNS. So again, you'll while that's not a big challenge in itself, it's one of the benefits of looking at a cloud hosting vendor. If in case your the particular IP of your machine gets blacklisted by the websites that you're crawling, you can always reset it and I mean thrash this VM and get a new one. Alright, so that's basically the hardware spec and the hosting, and then finally the actual configuration itself. So all the changes were primarily made in the settings.py, the Python file. And for the initial run, I've basically set it to use the recommendations from one of the documents in the Scrapy document itself. That's a recommendation for doing broad crawl. So essentially just walking through some of these. So again, this is a broad crawl. So some of these broad crawl configurations will not necessarily apply if you're doing focus crawls and benchmarking against focus crawls. So be mindful of that. So one, we are disabling redirects, and I found this particularly handy. One of the techniques many websites use to avoid spiders consuming too much of their resources is to actually keep redirecting. And that's one of the things that we would want to avoid. But in general, just avoiding redirects. That does preclude some sites from being indexed, like say for example sites, newer sites, or companies that have set up a new website, for example. They could potentially be excluded if there was a redirect. We want to disable retries as well. So if it didn't work the first time, we don't want to waste too much resources making requests. Um, this again is a broad crawl, so there's really no reason why we need to enable cookies. So enabling cookies does have a resource overhead, so it's been disabled. Have restricted the depth limit. So again, in case we come across websites that have lots and lots of content, we want to make sure that the spider doesn't spend eternity within these sites. So having a depth limit of 5. Restricted the timeout for downloads itself. So again, in case we come across any really slow sites. Want to be respectful of websites in terms of not I mean in terms of ensuring that we follow the guidelines that they've set for the robot.txt file. and also making sure that we don't put too much pressure on a given website. So again, just being a good citizen, if you will, a net citizen. So just ensuring that we do not burden the site with a lot of single requests. So essentially, what would happen in this case is once your initial few crawls can be very slow because you haven't got that many domains, but within a few minutes it'll have lots and lots of different domains. So we find that it's only your initial few requests that the crawl performance is very slow. Once you have a much larger list of domains, then performance is fairly consistent. So again, set the concurrent request to 100 based off of the initial settings suggested here, and we'll be revisiting some of this in the second one. Finally, in terms of the log level itself, just setting it to info, because even sending requests on the console does have an overhead, and it can be quite noisy to follow. So just setting it to info level and error. So that's basically the settings file. In terms of the extraction itself, so it's very basic. So it's only got two attributes. So one is the URL itself that we are logging, and the second attribute is basically a marking. I mean a flagging a URL. So of course, this is where your specific domain logic or content extraction logic would apply. So in my case, I'm doing some very basic checks on the page to see if it contains one of three keywords and setting a flag accordingly. So keep in mind that the more number of attributes that you have, and of course the content extraction logic will have a bearing on the CPU utilization as well as on memory. So as you can see, fairly simple content extraction, really nothing happening under the hood, and you can see the basics of the settings. So this is the context for the first run. So after running it for a period of time, so this basically was the end result. So as you can see here, it's given that this is a broad crawl, it could have pretty much run on forever because I did initially set the start URL to a directory listing. So it would have pretty much gone on for a very long time. So I've run the crawler for about 4.5 hours. As you can see, here's a start date and time and the end time. And as you can see from here, I've forcefully shut down the crawler. Otherwise, it would have gone on and on. And as you can see from the results, so we've it's crawled about 188,000 requests, and basically it had a average performance requests of somewhere close to 700 requests per minute. You'll also notice that it at the very end it does show you a quick summary of the various HTTP results or the responses. 200 is what we are basically looking for, but you can see from the sheer number of 404 requests and 301 redirect requests how dynamic sites are, or the internet is. So essentially, there's been a lot of sites where or pages that it could not be found and had redirects. So again, gives you an idea in terms of when you're doing broad crawls how dynamic the scape of the internet is. So that's basically the gist of the first run performance, but digging into some of the details. So just on the crawler performance itself. So of course, the internet uses TCP/IP or IP specifically in context of what we are discussing. So it's a bit non-deterministic, if you will, in terms of the performance. So these are just uh, the the estimates. I'm sorry, the benchmark for the first run that I've done. So as you can see, there's a wide fluctuation in terms of the pages per minute. So overall, or on average, it seems to be somewhere north of 500. But as you can see, it can climb to something over 1,000 pages a minute, and then in a few short minutes immediately drop down. So again, you'll have to be mindful of the performance characteristics. Again, there's things like latency and how that IP packet has been routed and into which servers. But essentially, this was a quick glimpse into the crawl performance. In terms of memory, one of the things you will want to be mindful when you're using Scrapy or Python in general is about the memory characteristics. As I mentioned, I've using the first configuration, the first run or the first set of configurations have run it twice, so just to get a sense of the performance characteristics. So as you can see here, the memory consumption is fairly steady. So in the first time, I've uh, I've I've shut down the crawler here, and using the same configuration, ran it a second time and shut down the crawler here. And in both these two instances, you'll notice how memory consumption is fairly steady. It doesn't release the memory till the crawler almost fully completes. But you can see that there's spikes in memory usage, and then it's kind of becomes steady, and then a slight increase in demand. There's You can follow the link here at the bottom that talks about how you can address memory leaks or look into memory leaks both within Scrapy, and some suggestions for using techniques within Python itself. Speaking of memory, monitoring memory and addressing memory leaks, it's already mentioned in the link earlier in the earlier slide. But one of the tools that you can use is to access the Scrapy telnet console. So if you telnet into the default port, or if you've set a separate a different port, you can telnet into it, and it gives you a quick sense. If you run this command here, it gives you a quick sense of how long objects have been living in memory. So again, you'll find that requests tend to have a very long lifetime, and particularly if you're doing broad crawls, some of the URLs that you set initially again tends to have a very long lifespan. Particularly in my case, the initial crawl, the initial URL was set to a directory listing, and hence a lot of the requests tend to stay in memory for a long time. I've used the in the previous screenshot and in all the charts that you'll see in this presentation. It's all from Microsoft's Azure's admin UI that I've extracted the charts. But if you wanted to go low level and have a look at how the memory is performing, again, I find this tool very handy. Use a watch and run the memory free command just to see dynamically every second. You can actually see how memory has been consumed. In terms of the CPU itself, as you can see, this is again using the same initial configuration, the first run, and using the same configuration again, a rerun of the same. So overall, you can see that again, because the URL scroll and the network characteristics tend to be a bit non-deterministic. You can see CPU fluctuations again, but overall it seems to be fairly idle. You can see that on average it's just about just very much under 20. So that means that there's plenty of room to play around with, particularly when it comes to CPU utilization. Again, one thing I didn't highlight earlier was on the VM, the Azure VM. Apart from Linux, the operating system, and Scrapy. There was no other installations, so it was a base Ubuntu version 14, a long-term support version, and with Scrapy and nothing else going on. So it's pretty much all Scrapy that's impacting the CPU and the memory. So now, having done the first run and seeing that there was a lot of room to play around, particularly in regard to the CPU utilization, the second run basically included only one key change, which was around adding or increasing the number of concurrent requests. So in the first run, you may recall that this value was set to 100, and in the second run, this value is being set to 500. No other changes were made. Of course, the content extraction remained the same. So with only this one change, the second run was performed. So again, the second run, just giving you a sense of the output. So the second run was run for a period of 12 hours, as you can see, close to 12 hours, about 12 and a half hours. So again, keep in mind when you're trying to shut down the crawl, it can take a while for the crawl to gracefully shut down unless you force it. And again, since we did crawl much larger set of sites, so you can see here that it was way north of 500,000 URLs that it crawled. And overall, the performance was about 1064 requests per minute as compared to the previous run where we had close to 700 requests per minute. In terms of the actual crawl performance itself for the second run, again we can see that overall crawls per minute was significantly higher. But again, we had to factor in these ups and downs, if you will. So even though you have added additional concurrency, you can see a steep drop and climb in terms of the crawl performance. And finally, in terms of the memory and CPU on the left-hand side, what you're seeing here is the memory footprint, and here you have the CPU. So again, this was run for a period of 12 hours, so it gives us a better sense in terms of overall utilization of resources. So in total for the 12 hours, it utilized north of 3 GB of memory. And as you can see here, this was when the crawler was started for the second run. Modest increase and then stabilizes, and interestingly there's a huge spike here, and then further we can see that the memory pressure seems to stabilize, and it's always increasing. It's one of the things you will want to be mindful when you're using Scrapy, particularly for broad crawls, is the sheer memory pressure, or the fact that it doesn't release memory as often as you'd want it to. So it's something that you definitely want to keep in mind. And if you're wondering why the graph just dropped off, this is when the crawler was gracefully shut down. So it once it was shut down, it started releasing memory. So if I waited long enough, you would have noticed that it would release memory almost completely, or memory from Scrapy, and just the OS would have come back to this level here. And then in the CPU, again, interesting characteristics. So you can see there's spikes and drops and spikes and drops. So again, it's a very dependent, I guess, in terms of the URL crawl. So you may recall from the previous slide that we had huge variations in terms of the crawl performance. So the CPU is going to be pinned by the number of URLs that was crawled. The other thing to keep in mind, of course, is in case of this benchmark, the content extraction was very, very minimal. So it was just about extracting URL and just doing some keyword search on the page. So of course, your content extraction might be a lot more involved. You might have a lot more conditions to check, or if you're using other techniques like machine learning based algorithms, so that's bound to have a much higher CPU overhead. So don't be misled by these CPU performance. Again, your performance benchmarking would be significantly different. The other thing to keep in mind is, again, in terms of storage, if you are storing the data or parts of the data in other long-term storage or NoSQL based storage or cloud storage solutions, it's definitely going to have an overhead again in terms of CPU and of course network bandwidth. So performance characteristics would vary. So that's something I've not factored into the benchmark, because again, it depends on the underlying logic of what you're trying to store. In this particular benchmark, of course, there wasn't any storage itself. The output itself was using the Scrapy command line, using the output, that is the dash O parameter. It was just saved into a CSV file. So IO, disk IO was fairly minimal, but that's something you will want to factor in for your individual benchmarking. So that's a wrap for the performance benchmarking. Hope that's given you some visibility and some insights into the performance characteristics of using Scrapy. Just before we wrap up, last thing I would like to highlight is that while we are on the topic of looking at performance and benchmark, of course, in this particular case, there was only one machine that was doing the crawl. So, of course, in a real life world, when you need high performance, you definitely want to look at using a much more scalable architecture or solution. So, you want to definitely investigate into the kind of design that would lend itself more on a scale out based architecture in case of a distributed environment. So these are two projects that you will definitely want to have a look at, particularly if you plan on using Scrapy. So we have the Scrapy cluster project, which uses Redis, and Kafka to actually distribute that crawl and have a significant performance and throughput in terms of the crawling capability and the kind of content processing. The other project that you will want to look at is Frontera. Very interesting in terms of how it sets us up for queues to allow for distributed processing and prioritization. So again, these are two very interesting and useful projects if you're trying to build large-scale distributed crawling infrastructures. So again, there are several others, but thought these two projects that would definitely help you when you're building distributed crawling. So that's about it for this video. So if you have any questions or comments, please leave a note and I'll try and address that. Hope the video has been helpful. Look forward to seeing you on the next video. Thanks everyone for watching.